So in lab 4, we will be using these micropipettes that will help in determining our precise concentration for each solution we'll be making. Now, how you use the pipettes is you push it kind of halfway down, then you put it in your solution that you're using, and then lift up, and then it's sucked up. Then you put it in your volumetric flask by pushing it all the way down this time. Make sure it's all the way down so that all your fluid is into the container you want. Now, the volumetric flask is right here, and it'll fill up a little bit with the sodium silicetate, and the rest you need to fill up with iron chloride, I believe. Yep, iron chloride. So a little bit of sodium silicetate, which you'll determine from your micropipette, and all the way up precisely to the line with iron chloride. Now you'll be having this little guy right here to add your iron chloride so it's exactly precise. You want a very precise measurement at that line. Now you'll be filling up 5 different solutions. This is a beaker for each solution. And your calculation, which is right here on this paper, shows you how much volume, the unknown, you'll be determining. Now this is a constant, this is the stock solution. This one would change depending up here on which solution you're preparing. Your volume of the volumetric flask is also a constant, and you're looking for your unknown. So M is concentration, B is volume, and C is concentrated solution, and D is the dilute. So in a moment here, you'll be seeing this on the computer. You'll have a source, color source specifically, and then your lens will sense it. It'll go through it and it'll detect the colors and the absorbency rate. And now the slope is derived from this equation, which is Beer's law. And here's the different slopes of colors.
So you open up Spectrascopy on the computer, and then you have your setup here, and you take a color sample and put it in with the arrow pointing towards the front, and then you put the cap on it so that you have no other light coming in. And then you look over here and find the highest wavelength. You can use these arrows to go to find the highest peak, and you're going to record this number there. And so since it was yellow that we put in, the color that's absorbed is going to be blue, which means that we're expecting a 435, 480 range of wavelength. So and you wipe off the sides to get all the fingerprints off because they absorb light, and that we don't want that interference. So now blue, we have our peak about here, and the wavelength is about 600. So from the chart, a blue-green would be, the absorbed color is going to be red, and then we're going to expect a 650 to 780 wavelength, which we have right here. And now let's try the reddish, pinkish color. So this, we have our peak around 500, and since it's kind of a red-purple, the absorbed color would be green, and it matches the 500 to 560 range because that is 511. Oops.